Hello, welcome to Internet of Things class, and this is going to be a 10 module course, and in the process we will take the module one after the other with different assessments to help us understand better what we are learning. And today we'll be taking the introduction to the Internet of Things, and we will look at the meaning and concept of Internet of Things, the evolution and history, the Internet of Things ecosystem and components. We also look at the IoT architecture and layers. We will look at Internet of Things and traditional computing system, and lastly we'll look at the role of Internet of Things in digital economy. The Internet of Things actually represents a transformative shift in how digital technologies interact with the physical world, and rather than solely on human-oriented device, the Internet of Things extend Internet's connectivity to everyday objects, enabling them to sense, collect, process, and exchange data autonomously. And that is why this module will have to introduce you as a learner to the foundational ideas that underpin Internet of Things, providing a clear conceptual grounding for understanding how interconnected devices are reshaping modern societies, industries, and economy. And the bottom line for this module is Internet of Things bridges the physical and digital world through smart connected system. Let's understand the meaning of Internet of Things. Internet of Things refers to the technological framework in which physical objects are equipped with sensing, processing, and communication capabilities that enables them to be able to connect to the internet and interact with other devices, systems, and users. And these things are embedded in sensors, actuators, software, and unique identifiers, allowing them to collect environmental data, transmit it over network, and respond intelligently based on predefined rule or analytical outcome. And the core concepts in this include the connectivity of physical objects, the sensing and actuation, the autonomous machine to machine communication, the data center operation, the integration of digital technology, and lastly the creation of smart and adaptive environments. Based on evolution, the evolution is closely linked to the advances in computing, communication technologies, and data processing. And although the term Internet of Things is relatively recent, the underlying idea of connecting physical objects to digital network has developed over several decades. And looking at it as per the historical milestone from 1960 to 1970s, that this is actually an early embedded system and industrial automation. For 1980s to 1990s, there was an emergence of networked device with M2M communication. In 1999, we have the Kelvin Aston coin, which coins the term Internet of Things. And in 2000 to 2010s, technological acceleration driven by miniaturization, the IPv6, and the cloud computing came to existence. And in 2010s to the likes of 2020s, the Internet of Things becomes the backbone of industry 4.0 and smart cities. And today and beyond, we have an integration with 5G, edge computing, AI, and autonomous systems. Looking at the Internet of Things ecosystem and its components, it actually operates as an interconnected ecosystem consisting of multiple components that work together to collect, transmit, process, and act upon data. And the components are the Internet of Things device and sensors, which is the perception layer. We have the connectivity and communication network, which is the nervous system. We have the gateway and data transmission layer, which is the intermediaries. We have a data processing and computing platform, which is the brain. We have the application and user interface, which is the interaction layer. And we have the security and management layer, which is the protective shield. And we can actually go through them one after the other in the notes. Looking at the Internet of Things architecture and layer, just like we've barely talked about briefly, but this is actually the architecture, and it is actually a structured framework that defines how Internet of Things systems are designed, organized, and operated, and it explains how data flows from physical device to digital platform. And we have five layer architecture. The first is the perception, which is the sensing layer, and at this phase collect data from the physical environment using sensor and actuators. And as per the second one is the transport or network layer, and for this it actually transmits data using wire or wireless communication technologies. And the processing or midway layer handles data storage, processing, analytics, and device management. The application layer provides user-facing services and domain-specific application. And lastly, the business layer focuses on system management, decision making, and value creation aligned with organizational goals. When differentiating between Internet of Things and traditional computing system, the Internet of Things differs significantly from the traditional computing system in design, operation, and application. And looking at it from the nature of device, we can see that Internet of Things uses specialized embedded devices. Traditional computing while traditional computing uses the general purpose device like the PC and servers. And as per the mode of interaction, Internet of Things emphasizes on machine-to-machine communication, while the traditional computing relies on human-to-computer interaction. Under data generation and processing, Internet of Things generates continuous real-time data, while the traditional computing relies on human inputs. Also, for scalability and deployment, Internet of Things is designed for large-scale distributed deployment, while the traditional system are centralized. And under the resource constraints, the Internet of Things devices are often resource constrained, and while the traditional device have ample processing power and memory. And lastly, as per the context awareness, the Internet of Things system are inherently context aware, while that of the traditional system lacks environmental awareness unless explicitly programmed. Looking at the last, which is the role of Internet of Things in digital economy. Internet of Things plays a central role in digital economy by transforming how data is generated, exchanged, and utilized to create value. And key contributions are one, data generation and value creation, which means that Internet of Things enable large-scale data collection, turning raw data into actionable insights. Also, it supports real-time monitoring, the predictive maintenance and processing optimization. Also, it enables service-based data-driven model like remote monitoring and usage based on pricing, and also it integrates with cloud, AI, and analytics to form complex digital ecosystem. It's also real-time data which enhance both operational and strategic decision making. Also, Internet of Things transform healthcare, transportation, agriculture, manufacturing, and smart cities as you'll be seeing it. And also, Internet of Things creates new role in development, analytics, cyber security, and integration. And lastly, Internet of Things enables connectivity in remote areas and supports global supply chain. Looking at Internet of Things as per sector, which is first healthcare. In healthcare, Internet of Things enables remote patient monitoring, smart medical devices, and data-driven care delivery. And the benefit of this is, for example, wearable devices are used in monitoring or tracking vital signs, and alerts healthcare provider in anomalies. Also, it helps in improving diagnosis. That is, data from Internet of Things devices supports early detection and personalized treatment plan. And the challenge under this is the issue of security and privacy in terms of protecting sensitive patient data from breaches and ensuring compliance with regulations like the HIPAA. And also another is the Internet of Things concept applied, talking about the sensing, connectivity, data processing, and application layer work together to deliver secure, efficient healthcare solution. Looking at security and ethical consideration in Internet of Things, as Internet of Things system expand, security and ethics becomes critical concern, and we have the security challenges as device vulnerability, data privacy risk, network attack, physical tampering, and we have the ethical considerations as per the data ownership and consent, the surveillance and privacy, the environmental impact of Internet of Things devices, and lastly the equity in access to Internet of Things enabled services. And the future trend in Internet of Things includes the AI and machine learning integration, the edge computing, the 5G connectivity, the sustainable Internet of Things, and digital twins. In conclusion, this module has provided a comprehensive introduction to Internet of Things, covering its meaning, evolution, ecosystem, architecture, and role in digital economy. And this foundation knowledge prepares you as a learner for deeper exploration of Internet of Things technical security and application dimension in the subsequent module. Thank you for listening.